All right, welcome to our final discussion of summer 2021. This is our Summer of Physics series. We're reading and discussing our third book of the summer today, The Jazz of Physics by Stephon Alexander, who happens to be a professor at Brown University and therefore is based in Providence, Rhode Island, which is where I am. I did not actually know that when I picked this out of the poll choices for the third book, but when I read the back of it, I went, oh, hey, it's like down the street from me. That's kind of cool. This is a neat book. I'm looking forward to discussing it with you folks. We'll start with doing introductions like we always do. So my name is Laura Williams. I'm a newly tenured associate professor of biology at Providence College in Providence, Rhode Island. And I think we'll just go by the person who's next to me in the gallery on my screen, which happens to be Joan. Joan, do you want to introduce yourself?
Hi, I'm Joan Williams, Laura's daughter. I'm retired and
you're my mom.
Yeah.
You said my daughter.
She's my daughter. I'm her mother.
We got like a weird Benjamin Button thing going on. Don't worry about it.
And I'm very happy to be included and have my mind broadened by these books and discussions. So thank you.
Excellent. Heather, do you want to introduce yourself?
I'm Heather Maseli. I'm an adjunct professor at Roger Williams University, which is in Bristol, Rhode Island. And I teach general education science. And yeah, I'm just happy to be here talking about books this time.
Yeah, thank you for joining us. This is your first book club with us. We're very excited to have you.
Oh, the first summer.
The first summer, yes.
Yeah.
The first summer series, yes. Nicole, would you like to introduce yourself?
Yes, I am Nicole Cyclio, and I'm sitting in a cave right now at the University of Northern British Columbia. This cave has sketchy internet, so I'm hoping it will stay stable. But incidentally, this is also the place where I will be teaching in the fall and the winter as a sessional instructor.
In that cave?
Well, not in the cave,
okay.
Just the building at large.
Got it, okay.
It would be kind of cool to teach at the cave, but like, I don't think this is a teaching space. I think this is a hang out and listen to your voice echo off the walls kind of space.
Okay, got it. I was like, yeah. You're teaching in the cave? That doesn't sound good. All right.
No, I'm not teaching in the cave. However, this is the first time I've actually found the cave and sat in it, so it's good. So
you can claim it as your hangout spot.
Yeah.
You're like, no, I don't want to do that.
It's going to be feasible. However, I mean, harmonics and oscillation and all the weird sounds in here do correspond with the topic of the book today.
That's true. That is true.
Yes. So along with this crew of some educators, I will be teaching forest disturbances in the fall and general bio in the winter.
Excellent. Yeah, and Nicole, if you feel like you want to take your camera off, because I know my experience is that with Zoom, if you start to have spotty connection, going just with audio might help. So if you need to do that at any point, feel free.
Thank you.
Something that happens. Okay, so thanks to everybody for being here. I'm very excited. I always enjoy talking about these books with folks. It's really nice to read something and then have a chance to discuss it with people. So the Jazz of Physics is the Jazz of Physics : the secret link between music and the structure of the universe. So we've already talked a bit about physics, obviously, because we've read two books that covered cosmology. So all three of these books end up addressing aspects of cosmology, aspects of theoretical physics. I will not make the claim that I could teach any of this stuff after reading these three books, but it was heartening, let's say, that I encountered some things in this book, this third book that we're going to talk about today, and I thought, oh yeah, that got mentioned in the other two books. I'm vaguely more aware of what that means now than I was before. Good job, me. So, when inflation came up and I was like, okay, yep. And the big crunch gets kind of mentioned, but not completely spelled out as the big crunch. And I was like, okay, Yeah, that was a Katie Mack thing. I remember that.
I do have one question, and that is,
Yeah.
did the chapter titles actually make sense? Because in the audiobook, they annotated chapter 1 through chapter 20, which was irritating because you could tell from the narrator that the chapters had names. So I was just kind of, I feel like you probably have more insight into the narrative structure of the book than I do.
Did
So I'm gonna
did they not give you chapter titles? Did they just
not
say
in
chapter
not in the
1?
text. Yeah, like, so the
Oh.
dude said it, like the guy that they hired to read the book, but like that's not the same as having a textual cue on a screen to actually know what the chapter's called.
Well, so I will say this, since you bring this up, I will say that I feel like the through line of this book was a little choppy. I got the sense that, and sometimes this happens, but I don't know if this is true for this author, but I got the sense that perhaps some of these chapters had been developed as independent pieces of writing at some point, and then were brought into the book and kind of built. Maybe that's not true.
Yeah,
I mean,
well,
maybe he really did sit down and write the thing from beginning to end, but
I agree with you that this felt interwoven without a linear arc that connected things,
Mhm.
you know.
which I don't know is necessarily a bad thing, but it was just like the structural framework of, for example, Katie Mack's book, which, I mean, she laid it out in the beginning where she said, I'm going to explain to you what we know about the Big Bang or how the universe started. And then each chapter is going to go through a particular theory about how the universe is going to end. And so that was the clear structure. And so you kind of knew when you were starting into a different topic, different theory. The Disordered Cosmos kind of, she was very upfront about kind of what she was going to start talking about. And she split it into, I think she called it phases, where she kind of had a theme for the phase and kind of explored different things with under that.
But from what I remember, some of her pieces were essays ahead of
Yes.
time. She had actually mentioned it in the writing, and I wasn't here for that discussion, but I found that at times I was like, why are we talking about this right now rather than someplace else? Whereas this one, I felt like it was almost, I felt like it was like his evolution of thought.
Yeah.
So sometimes it wasn't time linear because he kept going like back and talking about like, oh, when I talked to this guy, but like we're talking about the mid 90s, but we'd already been in the 2000s.
Yeah.
But it was definitely like how all the different threads of his music and his physics, like obviously things don't happen in a line in
Right.
any kind of research, right? And I think that was kind of interesting, but it was confusing. And I yeah, so
I agree with you. I very consciously, in about the third or fourth chapter, once I realized what you just said, Heather, that we were going to jump backwards and forwards in his personal journey. So we weren't, you know, the ideas that he's expanding on in this book, he wasn't going to develop them in a linear sense of like, let's start from when I was a grad student and now we're gonna, you know, and I think that's fine. And I just had to notice that and then decide to let go of the fact that like, was this before or after he was at Stanford? You know, it was kind of immaterial to understand what he was trying to get at.
It's going to take me at least 3 more reads to figure out how many postdocs he did, because that was what I was trying to figure out the whole time. It's just like, how many visiting
I think I
physicians did
counted
he have?
at least 3.
Yeah, and it seems like maybe he kind of ended up sponsored by one person, but then going different places and traveling around. I kind of got the sense that, I don't know if this is a good way to describe it, but it's almost like this book is structured as like, here's my central idea. And then it's almost, because he describes himself as somebody who will go to listen to jazz and take physics with him so that he can do calculations and work on physics and think about physics while he's kind of suffused with jazz as a way of helping him think. And I kind of wonder if this book is a little bit like how you would imagine his scratch paper sheets would look like once he's done, right? There's a central idea, and then there's all the kind of marginalia where he develops different aspects of the central idea. And the book kind of seems like that, he's got this central idea about the universe being musical, or at least that being a useful analogy for how you get structure in the universe. And then he kind of spins off all these different ways to think about it, or different elements to explore.
Yeah. And
Oh,
go ahead. Go ahead. You haven't talked yet.
I was going to say too, it was interesting because we've read 2 female physics authors, and this is a male. And in his book, how he would refer to, oh, we go grab a coffee and we have a coffee, or we grab a beer, whereas those are males. I never heard him say specifically like a female professor. So it's interesting in like how the patriarchy is maintained because of the comfort level of how you meet to exchange information. Or perhaps the females just didn't mention that, but I thought that was kind of fascinating. Like, oh, I had this wonderful idea, so I went to get a beer and I saw my advisor walking by, and I said, oh, come in here, I've got an idea, that he happened to be going by where he was. I thought that was very interesting.
Yeah. So this year I committed to only reading science books by females. And obviously I was like, okay, well, it's a book club. They picked one. It's also, he's also a Black man. So kind of still keeping with the diversity piece. But it's very different. I really read it as it's just written so differently from every science book that I've written, but that has been written by women this year. So all of the other 2 books that we read, I also read Sirens of Mars, which much like he had, her story was how she ends up working on the rover program. And it was oh, I just happened to run into this person. But it seemed a lot harder for her to do that in that story, or in her narrative. And then I read not a space one, the Sixth Extinction. But it was just very interesting to because I was like, wow, there's a lot of males in here. I think he mentioned 2 females. That was it, the whole book. Granted, physics, male dominated field, but I also when we were talking about the postdocs, I also felt I feel like physics academia is very different from other departments of academia. They are literally hopping from school to school to school to school to school just to sit in a room and do calculations. Whereas I didn't do a postdoc, but in bio, you go and do a postdoc and then maybe you do another postdoc, but it didn't feel it felt like he was literally all over the place, trying to figure this out. But I don't know if I guess that's normal in physics, but I don't know.
I wonder if there's, so one of the things that I think that this reading all 3 of these books has been helpful for me is to understand what a theoretical physicist does.
Yes.
Because I didn't know. I can't say that it kept me up at night. I wasn't like, what do they do? But it's kind of good to know, what is a cosmologist doing with their time? What is a theoretical physicist doing with their time? I'll just tangent really quickly to say that I wasn't present for this, but there's a funny story that somebody told about where the lab where I did my postdoc. Apparently there was one summer there was a poor unfortunate undergraduate student who just didn't really understand what the PI was spending her time doing, which was lots of data analysis, writing papers and writing grants, which takes a lot of time. And he apparently said something to the effect of, what is she doing? Just sitting around eating bonbons? And she had happened to like a ninja kind of come up behind him right as he said that, which was like, oh no. But it just kind of showed that it's hard to know what somebody's doing with their time if you're not in the field if you don't, if you don't know for sure. So it's been really helpful in all three of these books to get a sense of what they're working on and what they're thinking about. And one of the reasons I brought this up is because I think in biology, we don't spend nearly as much time trying to develop theory, which I think would be really hard to do in complete isolation. So maybe that's why they end up bouncing around a lot, because they need the workshops and the discussions. And he mentions a few times that there would be groups, the quantum gravity theory group, and they would have group meetings. And it sounded like if somebody was running those, it would be a theory workshop just in the group meeting, where they would toss ideas around and kind of try to, poke holes in them and see what they needed to do. And I think that's very different. I think that's very different from the way biological sciences operates, where you have a project or a hypothesis, but then you've got to go out and line up your equipment and do up all your experiments, and then you end up with a data set that either tells you like, yes, this protein, when you knock it out, it gives you this phenotype, or it doesn't. You go, okay, cool, now we publish the paper.
And we've already got those fundamental theories that we're working under.
Yeah, I was going to say, is there something called theoretical biology? I mean, biology is just there, isn't it? And you're evolving like the COVID. I mean, that evolved from another virus, but I don't know. You guys, is there theoretical biology?
I think you just hit it, Mom. I think the at least from my area of expertise, I would think the closest thing would be evolutionary theory, where you still there's the neutral theory of evolution. There's molecular evolution in particular still operates from a very theoretical, mathematical basis, where people make arguments about, if you have these conditions or this fitness landscape, like what are you most likely to see? So when you said, Mom, like where did COVID come from and I think that's maybe one of the major areas that there are still people working who could get a theoretical biologist who never goes out and does experiments and just plays with evolutionary models and says, if somebody else goes looking for this, you'd probably see this. I
think it remains to be seen whether somebody comes after us in the comments for this, like an actual theoretical biologist. But I'm going to sort of put up, as a suggestion, systems biology as well as developmental biology. I think those are two areas where we're still trying to figure out sort of not necessarily unified ways, but addressing generalizations of how biology is in and of itself generative in producing, the extant, fully formed chassis of the thing that's going to go about its way in the world, right? And
that
with
makes sense.
Systems biology, it's so, soaked in math, because you're making the attempt of like, how do we get an interplay between two metabolic pathways, or metabolic pathway that leads to like some kind of overt physiological function? Like, what is the system? Or do we just look at little bits of things that are systems in and of itself?
When I was thinking about it, I was like, just trying to like origin of life. Obviously, that's purely theoretical. So, I mean, there are places that I just don't, it doesn't like, it's not like, I don't feel like there's an entire field of theoretical biology. Like there is theoretical physics.
I think it'd be a rare biologist who builds a career publishing a bunch of papers that are theory based and never does an experiment.
Yeah.
I'm not saying it couldn't happen, but I think it's rare.
Yeah.
Whereas that they in theoretical physicists, from what we've seen from these three books, they work with data and they build in observations and they will test their theories to the extent that they can. But it does sound like you have a lot of folks who publish papers that are, here's our new model for how these things work. Here are the equations behind it. Eventually,
have somebody else find the data.
Get data that you could test this. Here's the predictions we would make.
Yeah. No, I found that too. Like I was reading through and he would be like, this thing was theorized by this physicist, but then supported by evidence by this group. And it was like, clearly there's a distinct, I'm sure they collect data, they talk about it, but it just doesn't feel like that's really the crux of their position. It's mainly sitting down and trying to think of these theories, which to me blows my mind. Could you imagine dedicating your whole life to like the field of theoretical biology, and then like I don't know, like I was waiting, I was like, what did you contribute to theoretical physics? And he got to it at the end, obviously, and I had no idea what he was talking about by that point. I will say by the end of this book, I was like, I'm done with sounds. And I don't understand D-brains or anything like that. But clearly he got somewhere, but it seems like it took him a very, very, very long time to get to something that he's like, it's been cited 200 times. And I was good for you.
Yeah, I completely agree with you that the intensity of the math got picked up a lot towards the end of the book. I think the last few chapters, I was like,
I was kidding. I was like, what's the point?
So you can only imagine how that comes through in an audiobook, because I was already not doing okay with that, like with the Maxwell equations. And then there was something else with a whole bunch of terms at the beginning of the book. I think it was the energy states stuff.
yes.
There were 3 sections where I'm just like, I guess I'll just continue unpacking my apartment and acknowledge that this is happening and wait until there's something I can understand again. So,
Well, so this is a good example of the first 2 books that we read by Katie Mack and Chanda Prescott-Weinstein. I'm always afraid I'm going to say her first name wrong because I knew somebody who pronounced it a different way, so it's stuck in my head, probably the wrong way. They very deliberately did not include the math, very deliberately, and we kind of talked about that. I think between those 2 books there was one equation, and Dr. Prescott-Weinstein said, "This is the only equation I'm going to give you.
Yeah.
Hang on." You know, this book was like, "What up? It's math, pow!" You know. How did that land for folks?
I mean, I looked at the math and I remembered it. Physics was never my favorite subject. For whatever, I was really good at math. Like I took like high levels of calculus, loved it. The second you start to put it into like real situations, it all just gets completely lost. And so then he started talking about strings and springs, and I was like, no, like that like, and which is terrible because I'm over here like, no, we need kids to like math, we need people to like physics, and I'm like, but it was somewhat helpful, like when he was talking about the equations, to see them, whereas sometimes I found like Katie Mack was talking about the equations but didn't show them. And so it was kind of hard to visualize what she was talking about sometimes. But once he started like deriving, like doing the derivatives and stuff and getting into like the Fourier transformations, and I was like, yeah, you've lost me in terms of the math piece. I'm going to keep reading to see what I can gain from like the paragraphs that you're not like telling me what the math means. But it was a lot harder to read, I think.
I'll
Joan,
go next.
oh yeah, Nicole, go ahead.
Okay, so I kind of feel like it's important to actually have a book like this out in the world, where it is, a Black academic getting, articulating deeply in the discourse of his field. It is really, really, a critical thing, I think, for people who are looking for identities that resemble themselves in the academy, to see that somebody reaches that point, that somebody's attempted to communicate all the things and all of his reflections about why he found this a rich inner world for him to develop into and to devote a profession to. And even the I actually kind of feel like, in spite of the very it was almost a vortex of music, physics, and schmoozing. That's the only way I could really describe the three sections of the narrative. But like that, it all kind of ended up at the end with Coltrane's Mandala. I think that had to happen. I think this book really gave Stephon an opportunity to show that there are sort of fundaments of Black artistic culture that have also interwoven some very, very deep analytical, cognitive process that is quite sophisticated. And I think making that a public body of work as this book is just such a key thing, and makes it one of those things that I feel like if I had a hard copy of this book, and I might just get one, is worth reconsuming, because it's such an important thing to understand, this aspect of jazz that starts to sort of bleed out of the cultural landscape. And like, I mean, if Coltrane was practicing 12 hours a day and then ultimately going to cosmological concepts to think about how he was going to use this music with some intentionality in his life and for artistic expression, like that is a very I don't know if I've read very many books about like artists or what artists did that actually get to a point of explaining that that's where they went with their development. That's all I'm going to say for now.
I agree with you, Nicole. And I think it's interesting too, as he's talking about his progression, how he says, woof, these people know more about this. And he expresses his uncertainty about his knowledge and his ability to grasp things, but he keeps going at it. And the other part that one of my places in the book I just laughed was when he was in the one advisor, and the advisor said, well, I've trained my mind to work on calculations while I'm sleeping. And then he goes, all I do at night is sleep. I just laughed when he said that part, because it was like, are you kidding me? Whoever that person was, I can't remember who it was, but I thought that was an interesting exchange. And I thought that's really good stuff to put in a book for people who are considering pursuing these professions. And it's not like, oh yeah, I just always got it. It just came to me. It's like, I struggled to get through this. I kept trying to find what my breakthrough was going to be. And I'm just so grateful. I think he was saying too, I'm so grateful for these people who saw something in me when I was losing confidence.
Yeah, I think that's excellent points made by everyone. Nicole just popped a little note into the chat that said so many imposter syndrome moments, even for him. Yeah, I have two thoughts, so I'll try not to take too long on both of them because I don't want to eat up a bunch of time with just me. But one of the things I really appreciated about this was how open and honest he was about the just like you said, Mom, the uncertainty that he felt about his own personal journey as a scholar, and how the best way for him to produce his best scholarship was not the traditional way.
Mm-hmm.
And that he had to, definitely through the support of a lot of good mentors, the situation might have been very different for him if he had not had supportive mentors in his career who recognized that that Stephon Alexander was not going to be a person who locked himself in a cubicle and covered his scratch paper with calculations until the sunset and then turned around and did it again. He talks at one point about going to I want to say it was like an M theory workshop. He got invited to this prestigious workshop where everybody was supposed to gather and go to these talks and develop these ideas. And he was like, yeah. And I started out, I was like, let's do it. Let's work on this. And the longer the workshop went on, the less I felt like I got out of it. And then I kind of started to disappear from the workshop. And then I ended up at the local jazz scene. But that worked for him.
Yeah.
Those were the surroundings that he needed to be his most productive. And I think it is so valuable to hear a successful scholar talk about the conventional path was not the right one for me. And had I tried to follow it, I would not have produced the things that I produced. Because I think, golly, I would hand that to any grad student, because I think grad students in particular get leaned on really hard, sometimes by their PIs, sometimes by just the environment, that you should just science all the time. If you're like not sleeping, then you should be doing science. And apparently you should train your brain to do science when you're asleep. And you cannot function like that. You cannot function like that. And I already told this to Mom, but it makes me think of when we did our Summer of Scientists and we read the Dark Lady of DNA about Rosalind Franklin. And she had a stellar career, even if you don't discuss the DNA double helix, like tobacco mosaic virus and all this kind of stuff. And in the book, she would be like, I don't really want to do anything right now. I'm going to go hang out in the Alps for 6 weeks later. And I remember reading that being like, you do what? But I think these are good reminders that the nose to the grindstone mentality that I think gets baked into academia now is not healthy. It's not healthy for anybody.
I saw a tweet. It was actually critiquing American academia versus like European academia. And it was like, European out of office reply, I'm out of the office for 6 weeks to go to the Alps, right? Like, I'll talk to you later. And it was like, the American one was like, I'm out of office for the next 2 hours to get a kidney transplant. But I'll be checking my email in the meantime. And it was like, oh, that hurts.
But it's true, unfortunately. So I think that's just, gosh, incredibly valuable for him to have put that down on paper in an accessible book like this, and to talk about the places in his journey where other people who were already established and already prestigious said, you should be going out and playing jazz. And I mean, he talked about a couple of occasions where someone just point blank asked him, like, what else do you do besides physics? And he was like, well, I kind of played saxophone. They're like, okay, then that's what you should be spending some time doing as well. Like for someone to have said that was important as well. So that was one of the things I wanted to mention. But then the other thing I thought was really striking kind of builds off what Nicole was saying, which is, I just did not appreciate the extent to which musicians, both in jazz and outside of jazz, have engaged with theoretical physics to a greater extent than I have. I mean, he talks about like Brian Eno, who I own some of his albums. I like his music. I mean, Coltrane, just the discussion of the level to which Coltrane was engaged with this was really incredible.
One thing I wish I had when I was reading this, that it was like an interactive book, like that, like when he talked about chords or music or something, like I wanted to go find a piano and like play the notes that he was playing, or like hear examples, or hear Brian Eno or Coltrane, the songs that he was talking about, because I felt like I was missing something, because I'm not as familiar with those pieces of music as I am other pieces of music. And just to be able to be like, oh, I hear it, I feel it. Because I played violin when I was in school and was pretty good at the music piece of it. So I love listening to like the underlying things that happen in music. And I just felt like I want to know what you're talking about right now, because I never took music theory. So I can't like hear the chords in my head, but if I could have someone play them, I'd be like, oh, I understand what you're talking about right now. So like, that's what I really like. I found myself like trying to Google like a keyboard app so that I could hit the notes to hear what, and I couldn't find one that you could just play. Like they're all like games and stuff. But that would be really cool to like turn this into like an interactive book with links to the songs and that he talks about. But I found myself, I was like, oh, I'm gonna have to go find some of these albums. I actually Googled like the rap at the beginning. I can't remember who it was.
5%, was it when he was
It was
young?
part of the 5%ers. It was
Yeah.
the I don't know if I'm going to be able to find it. Oh, here it is. It was Rakim. I ended up Googling it to see what he was talking about and like how it was different from the like the mainstream hip hop that was coming out. And I mean, this was as hip hop was becoming a genre. And but I felt like I was missing that throughout the whole book. Like I wanted more. I wanted to hear the song about the Kepler's orbits. And I Googled that and it was like, you have to get it on a CD at the library. And I was like, but I want to hear it now. So because it was actually like a scholarly paper, and then it has like you could buy like the CD of it, and it was just really, I was like, I want to hear it. I want to know what you're talking about. I want to hear what they thought what Kepler's equations turn into music. Like I want to hear that. But I was also like I never realized how I never realized how many jazz musicians are over here thinking about cosmology and theoretical physics. Because even the jazz musicians that he was talking to throughout, like his jazz mentors were like, oh yeah, no, that's something we think about a lot. And I was like, okay.
I think
Yeah.
one thing that comes through, and like it's not explicitly said, but I think for all of the other sciences, including the ones that we've been involved with, it was very clear in the book some of the benefits of improvisation in terms of like getting the mind to be more flexible with ideas. But like he spent a lot of his career having to throw out ideas that just wouldn't work or just wouldn't reconcile, and like I sucked at that in all of my grad school and postdocs, and I'm just like, it just seems like, but I mean, it's the same thing with improvisation, because he has one whole chapter devoted to that where he actually talks about like, look, this is actually, and like it was very relatable because we in high school band, there was a guy who came in who kind of discussed sort of the grand rules of improvisation and like the fact that you actually need to practice all of your scales, including like, your, what is it, the harmonic minor, the chromatic minor, I'm getting it wrong, but like to have enough dexterity with playing things through, and he talked about that, like knowing your main motifs and being able to play them in all the keys so that you actually have a clue of where to start inside the context that you're in, and it's just, and how to change if it doesn't work. And like the idea, like it just sounds to me like within the discipline of physics, there's probably a big advantage for people being ready to chuck away things that just aren't going to work and move on to the next thing that we sometimes don't see in other disciplines. And I feel like in and of itself, that's a very beneficial way of understanding how to navigate through a knowledge base, whether you get it from a musical hobby or whether you get it from discourse like the ones that take place in all of those physics working groups that
I think too the notion that part of what, and it's funny because now three of us have talked about that we have a background in music, but I think we didn't get any music theory. Is that true? I didn't do any music theory.
nope.
Mom, I don't. you didn't play an instrument in school, right?
No,
Okay.
no.
My college roommate, however, did take a ton of music theory because she was a music education major. So she had to, music education at my college was a very difficult major, which a lot of people did not realize. Because you had to be able to rudimentarily, do at least rudimentary playing on all the instruments.
Mhm.
And then you had a specialty instrument, but then you also had to take all the music theory and music history and so forth.
And you had to like, I had a friend that was a music ed, and she had to also be like a good player on her primary instrument. Like,
yeah, it was
you had to be up to a very high level.
It was a tough major. Because I mean, sometimes people would be like, oh, music ed. Like, no, that's a tough major. What one of my things that I remember is that she would, for part of music history, their exams were basically, you get a random clip played and it's tiny and short, and you've got to identify like the composer, the era, like as close as you can get to what it actually is. Like you need to be able to do that. And so the best way that you can study for one of those is just listen to a lot of music. And so she asked me if this is okay. And so for a time, what she would do is she would just play stuff, and while we're falling asleep, like, because we'd share the room, right? And so she just like, is it okay if I play this stuff? I'm like, yeah, that's probably fine. I don't, have any. And then when we went through the Gregorian chant phase, and that was a little terrifying because there's like Hildegard von Bingen is like a classic Gregorian chant type thing. And it's all very nice and soothing until you get to a point where like the devil is confronting people and there's lots of yelling all of a sudden. So that was a little alarming, like a half an hour into being asleep, you're like, what's going on? But I think the elements of mastery that you have to have as a musician to be a good musician, and the elements of mastery of the math you have to have as a physicist, they're so similar, more than I really realized before reading this.
Yeah.
And I think the notion with improvisation, as Nicole was saying, part of it is to be a good improviser, you need to know what you can break and what absolutely can't be broken. And I think that's part of what's going on with what he talks about with physics. So what if you've got the standard model of physics, or you've got this particular theory or this particular equation, what can you break to discover new things or push yourself a little farther to push the physics farther, and what can't be broken? And so he talks about, the speed of light being invariant, but only because if you believe in the expansion and contraction, Big Bang, Big Crunch, cyclical universe, the speed of light is only invariant in our particular incarnation of the universe because of the way everything fell out during the expansion. But once it contracts again and expands again, all those constants can end up somewhere else. Maybe you get something different. I think kind of just what you said, Nicole, I think you jazz improvisation in particular probably helps you practice the skills to say, I'm going to try to break this and we're going to see what happens.
This is really interesting because not music improvisation, but like acting improvisation is a huge part of like science communication, or like just communication in general. Is like being able to just improvise helps you to build skills to communicate clearly. So it's really interesting because again, you have these rules of improvisation. When you do an improvisation skit, there are rules. You can't break the rules, but you can skirt around them and do all sorts of different things. But ultimately the end goal is to have like this cohesive story. And it's just very interesting to think about like how all of those improvisation skills, whether it's communication or music or, just being able to know where to push and where to step back, and that's how you understand how to open things up.
Yeah. Mom, are you trying to unmute yourself?
Yeah,
Yeah, there you
push
go.
the wrong thing. I was going
I
to
can see it.
say, lots of buttons up there. I was going to say too, one of his favorite words seemed to be chops in this book. He seemed to use the word chops a lot. And changing the subject a little, I think was it Kepler who had all the information from the scientists he was with, that he said that Kepler had, was it polio or something? And he could hardly see and he had crippled hands, but all this fantastic work he did. Oh, he really incorporated how people overcame things to accomplish things in the book to himself, and then going back to referring to a previous scientist. And I thought it was interesting too, the way he wove philosophy, the philosophers, into the development of physics. I thought that was interesting also.
I always regret taking philosophy of science as a freshman in undergrad. Like, I wish I could go back and take that class again, because I feel like I took it, it was cool, it was awesome, but I didn't have the understanding of what science actually was at the time, that I feel like now if I went back and took like a philosophy of science class, it would just make so much more sense. I would remember it. I don't remember much of it at all. But yeah, I like Pythagoras coming out, and Plato and the Platonic spheres. And I was like, this is all like tickling something way back in my memory, but it's not, like, I took that 20 years ago. So trying to remember it, but I feel like that's something that I would love to like revisit today. And this was kind of one of those like, oh, there's a lot of stuff I probably learned in that class that would have helped me understand this a little bit more.
Yeah, I think it was called Pathfinders. I don't know if Nicole, you remember, by
Yes,
Jim Maseli.
Yep.
There was a great book that we read a couple summers ago that was about the history of science and history of philosophy of science in kind of the Middle East, Islam and Arabic and so forth. And that was awesome. I was really glad we read that, because it brought to mind, I remember finishing the book and being like, I think it's absolutely ridiculous that we don't know half of these names from our K through 12 in college, especially college STEM education. It's just an absolute shame that we don't know these people more. But yeah, that it's interesting to see how things interweave, and that it's been happening for a while. You know, the music of the spheres, the idea that he's the central idea that he's developing here about the universe. Potentially, you can think of the universe as being musical, and you can think of how the structure of our universe as we observe it emerges from early incoherence, I guess. And what sound has to do with that, and are there analogies that can help us understand this, I think builds on, which he talks about, some long-standing ideas. I think one of the things that I do like about the way he approaches things is I think there are some people who will like to take like modern science, and if they do refer to historical science, they'll go, well, so-and-so proposed this idea, but it was really, really wrong for all of these reasons. And I guess that was fine that they did that at the time, but now we're better and we know things more. And here's what we know now. That's great. And one of the things I do appreciate about the way he approaches past his kind of historical perspectives is he's very generous about, they had this idea. It was a really interesting core idea. I mean, some of it was completely wrong, like, no, the universe does not go around the earth. But despite that, it was a really interesting idea. And here's, I think he's very generous about kind of pulling in the threads of what you can still use as inspiration, which I don't think a lot of people do. I think a lot of people like to try to stake out a claim for modern science by contrasting it with all the ways that past perspectives failed. So
Like
that's,
I actually had no idea that like it was Pythagoras, and then Newton built on Pythagoras's work, and then Galileo worked on Pythagoras's work, and then Newton worked on Galileo's work, and then Einstein. Like it was all the same. It was all building off of the same ideas. I had no idea. Like I didn't even know that. How did I not know that? And I think I like that he was generous. Like he was like, yeah, no, the earth doesn't go around the sun, or the universe doesn't go around the earth, but he wasn't wrong. He was using the knowledge they had at the time. And right now we have vast amounts of knowledge, but we don't have all of the answers. So who knows 500 years down the road what science is going to tell us then. And we're going to be the ones that they're looking at like, they didn't know anything, right? So I think that's fair. I think that's a great point, that he really did build this story about how science evolves using, and then he tied it all into how all of these people were really interested in music and geometry and, math, and it all kind of played together.
yeah, it was a really interesting read. We're about 5 minutes from 2 p.m., so I want to respect folks' time. Does anybody want to offer any kind of closing thoughts? Anything we didn't touch on that you wanted to just mention?
Well, I was thinking while I was reading it that I have never listened to that much Coltrane, and I wish I would have thought of, finding time to pull it up on YouTube and listen to like is it called Giant Steps, one of them? And then what's the one at the end that Nicole said that it ended with?
Mandela, I think it is.
Something like that. So I do intend, though, when I'm sitting down and I'm like looking around on the internet to see if I can find and listen to some of that, because I just really found that fascinating.
Yeah, I agree with you. I actually think that having read this, I felt the same. I was like, oh, this gives me something to go search out to listen to. And I will say that I think my personal appreciation of improvisational jazz was not great before this, because I didn't really understand it. I didn't really understand how to approach it. I hadn't spent that much effort trying to figure out how to approach it. But I think that Coltrane can be challenging to listen to if you don't really appreciate what he's doing. But I think having read this gives me a jumping off point to develop that appreciation, which I'm happy about, because that is an area of my listenership that I think is kind of sparse right now. And I'm always happy to discover new things. So that's a good outcome as well. Overall, I'd say I think this is a really fascinating book. I would encourage people to read it, but I would say don't sweat the equations. There's some of that you're just gonna have to let it wash over you. Be like, okay, Maxwell, he said some stuff. That's good.
I did find like the story that his writing was actually very well done. Like I read this faster than the other two books. I felt like when he wasn't drowning me in equations, he was telling a really good story. Whereas I think both Katie Mack and Chandra Prescott Weinstein, they were both so concerned about not putting the math in that they kind of bogged down their writing a little bit to a degree, that I found it was much more difficult to read the actual text. I flew through this in only a couple of hours reading it. So I agree. I think it was a great book to read. I'm glad I read it.
Yeah, Heather, I'll totally agree with you. When I picked this up from my local bookshop, who had it just in stock, I assume because he's a Rhode Island author, I flipped through it like walking out of the bookshop, and I saw all the diagrams and equations, and I thought, oh man, I better get started on this because this is probably going to take me a while. But I agree with you. I actually was like, oh, he's moving it. He's not, it's
Mhm.
not like you feel like you're reading a textbook. It's not like you're like, oh gosh, I'm going to have to read that one single page 8 times before you can go, okay, all of this math didn't land with me, but it kind of doesn't matter. I'll just keep going and I can pick up the thread of what he's trying to do.
Yeah, he did a great job of doing that, of like making sure that the reader understood what the implications of the math were without having to like bog it down. Like he did bog it down, but like at the end of every paragraph that he was talking about math, he was like, and this is what this means. If you're, it really felt like he was like, I know most people might skim over the math, but here's what the actual application is. And I thought that was really well done. And like I said, I read it much faster than I read the other books.
Nicole, any final thoughts?
It makes a lot more sense to me now why I was bewildered, because obviously the audiobook didn't have the diagrams either. But one thing that I guess still resonates with me with that book is the discussion of his interaction with 5%ers on the bus and their recognition of the fact that he was studying things like calculus. And I think that idea, that very important idea of them sort of looking out for him as a form of community care, and also recognizing that as a member of the Black community, that these types of academic pursuits, I think to some extent it was implied that this was sort of a gateway to some degree of mobility and survival, that there's this interesting interweaving of this appreciation for developing mental acuity, not just for survival, but to just take in more of the world, to refine whatever your practice is. And I do kind of wonder to what extent that interaction shaped how outgoing he seemed, and his willingness to take risks with discussing his ideas with colleagues, introducing himself to new nuclei of the physics community. And of course, this book doesn't focus a lot on a lot of his approaches to mentorship, but I mean, he does discuss things like taking postdocs along. So I feel like there's a lot of reference to just having the right conditions and the right people around you to support ideas, which again, like the supports of having your theoretical understanding of how to improvise, and also the fundamentals you're working within your discipline, in the case of theoretical physics, are sort of the supports that also create the platform for something generative and improvisational when the time's right to try and deploy that sort of thing.
Yeah, I think you're right. I think those are valuable things to think about as we head into the fall semester. New set of students coming in to get some learning and mentoring of their own. I think maybe my last note, and then I'll let you guys go, because it kind of builds off what Nicole said, and it also is something that my mom and I had chatted about recently, is the other thing that I think is interesting in here is he's very willing to talk about good mentorship. In his case, also involved occasionally people telling him, you don't want to do this anymore, go back and do the other thing. Like, he had this brief foray into neuroscience where he's like, I'm going to do biophysics. That's what I'm going to do instead. And he went off and joined this biology group, and he was there for a bit. And then, as I remember it, the biology mentor kind of went, so I really do feel like theoretical physics will eventually have a great place here, but maybe it's not now. And kind of sent him back to the world of theoretical physics and cosmology. And I think that's valuable too, is he's quite successful in his field, but he didn't take the logical A to B to C to D. He kind of took some, maybe I don't want to do that, maybe I want to do this instead, and kind of zigzagged, and still ended up in a place of success. So I think that's an equally good lesson for people to know. All right, well, thank you so much, everybody. So this concludes our 7th summer book club. Shocking but true. And I really appreciate people taking time to read the books and then also join for the discussions. It's always great to have a chance to chat with people. Makes the reading experience for me all that much better to hear everybody's thoughts about things. Well, I always plan to do it every summer. Coming around in the spring is usually when I start to rev up. I always welcome theme ideas, and you can see our past themes from our past years on the website, which I'm updating but fighting with WordPress about. So it'll get there. But thanks everybody for a really great summer book club. I really appreciate your time, and good luck to folks who are starting up for fall semester. It's going to be exciting. We're going to make it. We're going to get there. All right, folks. Thank you.